Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to your science class conducted by SLS Montessori in High School, and I am your science teacher Aman. We are going to continue chapter number 6, Air and the Atmosphere. Today, I'll be explaining you the subtopics important processes that involve oxygen and properties and uses of carbon dioxide from the topic Properties of Gases in the Air. At the end of the lecture, you'll be able to understand the importance of oxygen. You'll also be able to know about the properties and uses of carbon dioxide. So our subtopic is important processes that involve oxygen. As we know, oxygen makes up 21% of air by volume. Oxygen is a highly reactive element and is easily capable of combining with other elements. Oxygen is involved in many important processes, and they are rusting, combustion, photosynthesis, respiration, and oxides formation. Number 1 is rusting. Rusting is the process in which a brownish substance, iron oxide or rust, is formed when iron reacts with oxygen in the presence of water. Rusting cannot take place without the presence of oxygen, as we can see in the chemical equation. You must be thinking, what is a chemical equation? A chemical equation is a way to represent a chemical reaction using the element symbol. For example, iron is an element and has the symbol Fe. The same way, oxygen is an element and has the symbol O2. Let's have a look at the equation. Here we can see when iron reacts with oxygen in the presence of water results in rust formation. Iron, that is Fe, plus oxygen O2 in the presence of water H2O results in Fe2O3, that is rust. The next one is combustion. Combustion means burning. Oxygen supports combustion. If substances need to be burnt, they need oxygen from the air. Look at the equation. Here we can see when methane CH4 combines with two oxygen molecules, that is 2O2, gives us carbon dioxide CO2 plus two water molecules 2H2O plus heat. The next process is photosynthesis. Photosynthesis is the process by which plants make their own food. During photosynthesis, oxygen is released as a waste product. Now, the equation of photosynthesis. When 6 carbon dioxide molecules, that is 6 CO2, combines with 6 water molecules, 6 H2O, in the presence of sunlight, gives us glucose, that is C6H12O6 plus 6 oxygen molecules, 6O2. So, glucose is produced as a food for the plant and oxygen is released as a waste or byproduct. The next one is respiration. Respiration is the reverse of photosynthesis. Respiration is essential for all living beings, whereas photosynthesis takes place only in plants. How it's the reverse of photosynthesis? Let's have a look. Here we can see that in photosynthesis, glucose and oxygen are the end products, whereas glucose and oxygen are required to perform respiration. Means the end product of one process is the vital ingredient of the other process to take place. The next one is oxides. Do you know what is an oxide? An oxide is a compound of oxygen and another element. Oxygen combines with all the other elements except for the rare or noble gases. Most metals burn in oxygen to form metal oxides. For example, when magnesium reacts with oxygen, it produces magnesium oxide, that is a white powder. Here we can see magnesium, that is 2 Mg plus oxygen O2 in the presence of heat or when heated gives us magnesium oxide, that is 2MgO. Here we can see a piece of coal. Non-metals also react with oxygen in the air to produce non-metal oxides. Carbon reacts with oxygen to form carbon dioxide. Do you know what is carbon and why is it a non-metal? Carbon is from Latin word carbo, which means coal. Carbon is a chemical element like hydrogen, oxygen, lead, or any of the others in the periodic table. These are nonmetals which have characteristics like low densities, poor conductor of heat and electricity, etc. Let's have a look at the equation again. Carbon, symbol is C plus oxygen O2. When heated, gives us carbon dioxide CO2. The next topic is carbon dioxide. Carbon dioxide, that is CO2, is also an important gas that has many properties and uses. Carbon dioxide makes up about 0.03% of the air by volume. Let's discuss some of them. First of all, we'll be discussing about the properties of carbon dioxide. Carbon dioxide is a colorless gas, means it has no color. Secondly, it is denser than air. How? How can we check it out? Solid carbon dioxide is known as dry ice, which has white color. Whenever solid carbon dioxide is heated, it does not melt, but sublimes, means form the gas. As the dry ice vaporizes to gaseous state, some of the water vapors condense in the air to produce a white fog that sinks in the air. This shows that carbon dioxide is more dense than the air. Next property is it forms carbonic acid when dissolves in water. Carbonic acid is a weak acid with the chemical formula H2CO3. It is the reaction product of carbon dioxide and water. Carbon dioxide is not flammable, means it does not catch fire, nor it supports combustion. Now come to the uses of carbon dioxide. Here we can see a glass of fizzy drink. The bubbles in fizzy drinks are caused by carbon dioxide, the fizz that bubbles up when you open a can of soda or Coke is carbon dioxide gas. When carbon dioxide dissolves in a liquid, gives rise to fizz, and this process involves carbon dioxide under high pressure. When the pressure is removed, the carbon dioxide is released from the solution as small bubbles. The next one we can see here, fire extinguishers. Carbon dioxide is used in fire extinguishers to put out fires, as carbon dioxide does not support combustion. The next one is carbon dioxide is used to make breads and cakes rise. How? Whenever we need to bake a cake, we use yeast to make its dough rise. Yeast is a single-celled microorganism and is a type of fungus used by humans to make bread or cake, etc. In baking, yeast converts the fermentable sugar in the dough to carbon dioxide, which causes the dough to expand and give rise to soft and spongy texture of the bread. The next one is carbon dioxide is one of the essential ingredient used by the plants in the process of photosynthesis, as we can see in the equation. Sunlight, when combined with carbon dioxide and water, resulted in glucose, that is sugar, plus oxygen. So here we can see that carbon dioxide is one of the essential ingredient in the process of photosynthesis. Now, is it possible to check the presence of carbon dioxide? Yes, it can be done. In the laboratory, when carbon dioxide is bubbled into lime water, it turns lime water milky. Now, you must be thinking that lime water is the lemon water or lemonade. No. This is the calcium hydroxide solution, which is colorless and is bitter in taste. Let's have a look at the equation. Carbon dioxide, that is CO2 plus calcium hydroxide CaOH whole 2, gives us calcium carbonate CaCO3 plus water, that is H2O. So these are the element symbols that we are using here and the chemical formulas as well that are used to represent this chemical equation. Carbon dioxide as byproduct. Carbon dioxide is a byproduct of many important processes. It is usually produced on large scale by heating calcium carbonate in the form of chalk or limestone in lime kiln. Limestone is a rock formed mainly from animal remains, and kiln is a furnace or oven for burning, baking or drying purposes. Let's have a look at the equation. Here we can see calcium carbonate, that is CaCO3, gives us calcium oxide CaO plus carbon dioxide, that is CO2. So whenever calcium carbonate is heated, gives us calcium carbonate or limestone is heated, gives us CaO, that is calcium oxide, and releases carbon dioxide as a byproduct. Now come to the book pages. Here you can see book page number 62. Highlight the names of all the processes that involve oxygen. Then write down question number 6. What are oxides? And the answer is in the para of oxides. Now again on page 62, topic is carbon dioxide. Write down question number 7. Write down the properties of carbon dioxide. And the answer is in the first line, and then the other points are in the middle of the para. Question number 8. How carbonic acid is formed? And the answer is in the third and fourth line under the topic. Then comes question number 9. How fizzy drinks are made? And the answer is in the second line under the topic. Now come to page number 63, question number 10. How the presence of carbon dioxide can be tested? And the answer is in the first para of the page. Highlight both the chemical equations on page number 63. I hope you have understood the lecture. So at the end, I would like to say stay home, stay safe and keep learning. Allah Hafiz.